Hey, and welcome to another video on Max Developing. And today I want to explain to you the principle of inversion of control. And to be honest, it is a principle that I had difficulty myself grasping when I heard it for the first time. And as many people do, I also mixed it up with the technique of dependency injection, which actually kind of works as an enabler to fulfill this principle of inversion of control. But we'll get back to this later. Let's just assume a simple scenario, something like a message that interacts with some sender. And that message contains a function, let's say add sender info, where it is passed a sender and where it just adds to itself some information about the sender. And what that actually does, it creates a dependency here to the sender, and that means that the implementation details of our sender entity here dictate the behavior of this message class. So it has control over how the message class is acting. And what we are doing is when we are fulfilling this principle of inversion of control, we are introducing a kind of contract that the message says or the message uses to fulfill its purpose. And if it means that it cannot use any entities who do not fulfill this contract here. So if the sender fulfills the contract, then the message is able to use the sender. And if the sender is not willing to fulfill this contract, then it says, go to hell, basically. And in terms of object-oriented language, like C#, we could use here a interface simply, and we could call it the iSender interface. And the message would work on this sender interface. And basically, it would require of all senders to implement this interface. Otherwise, it simply simply all the other senders will be of no use to the message here. And to further separate this message class from the rest of the architecture, we often use the technique of dependency injection. It can be something as simple as having a constructor for the message where we simply inject the sender here. So that means that the message class actually doesn't know at all about the implementation details of the sender. It doesn't even care about any implementation details of the sender. It could be actually anything, basically. All that it cares is that this contract here is fulfilled. And what that achieves for us is that we have a very good testability of our entities here. So we could simply write a unit test where we pass a dummy implementation of this iSender class here. And what it further achieves is a separation of concerns here, so that this message class is not coupled with any implementation details that the sender may need. So, for example, it could be an email sender, or it could be a messenger sender, or it could be any sender, and it would contain any implementation details that the message does not really care about. So we have the message class stands for itself in essence. So those are it's a very important principle in software architecture and software development, because with this principle you can achieve a very clean architecture. And we have looked at this principle here in the context of smaller entities or classes, if you move in the realm of object-oriented language. But this principle is also widely used in a whole application architectures. So for example, ASP.NET Core leverages this principle, and it even natively supports and encourages you to use dependency injection for your applications. And this principle of inversion of control there looks something like this, that you have the region of app core that, for example, contains the business logic or the entities there, but it also contains certain interfaces that it uses, that the business logic, for example, uses to fulfill its functions. So you have this app core thing here, which I basically call it a region because it might not necessarily be one project. Maybe you will split this into different projects depending on the details of your project requirements. So I will call this a region here. And then there is a region of infrastructure that, for example, takes care of the data access. Can of course also do many more things, but for example, it could communicate with an external SQL database here, and we'll implement the details for that. And we have a third region, which is the web app region, which takes care of the requests that are sent to it, and stuff like this configures the web environment, for example. And how the principle of inversion of control is achieved here is that the application core defines certain interfaces that it uses. So it does not know anything about how the data gets to this business logic here. Only thing that it knows is that those contracts, those interfaces are fulfilled, and the data access technology behind that could be basically anything, and it does not really care about that. So the infrastructure project, of course, references the app core project to implement any interfaces that it might need, for example, for data access. And the web application, of course, also requires a reference to this application core here, and sometimes it requires a reference to this infrastructure. But let's make this reference here a little bit more weaker, because the only place where this web application requires the infrastructure is to actually put the actual implementations of the interfaces into the service container that it has. And the service container is the dependency injection mechanism behind this web application. But you could even go so far and mitigate this reference completely. If you have a mechanism to load these implementations dynamically from the assembly, then you could remove this reference completely, actually, because you normally never use the actual implementations here directly, except for, as I said, for registering it with a dependency injection container. So the principle of inversion of control here achieves that this application core kind of stands for itself, basically, which makes it very easily testable. So you can very easily unit test this business logic here. You could write beautiful unit tests for this, giving dummy implementations for the interfaces here. And the application core doesn't need to know anything about implementation details, for example, of the data access layer here. So this achieves a very clean architecture, basically, that helps you, especially when your application is evolving and you want to scale up your application. This is definitely the way to go. You want to have an architecture that doesn't start to crumble when you have new requirements for your application. You want an application structure that is very solid and at the same time very flexible. And this clean architecture definitely achieves this, because you could, for example, let's say while our application is evolving, we want additional database support here for, I don't know, MySQL for example, and we could simply add these implementation details here in the infrastructure layer, and we would not need to change anything here in our add core project, for example. And this way you are basically good to go to scale your application up, and to also be less stressed as a developer because if new requirements come in, then you are prepared for that with a clean and flexible architecture here. So that's it for this small video on the principle of inversion of control. If you have any questions, or if you have any suggestions, or any mistakes that I have made here, please leave a comment down below. I'm always eager to hear from you, to hear about your experience, your opinions, and thank you for watching. Bye.